Hello everyone, welcome to this video where I'll be discussing an exciting project I recently completed as part of the Emertxe IoT internship program. This project focuses on creating a simulated home automation system that integrates IoT technology. I am Jedediah Tete. Before we dive into the project, let's see the project outline. We'll talk about the introduction, requirement, design and implementation, and then results and conclusion. But after this presentation, I'll do a demo. I'll demonstrate the project for you to see. The project is as a result of an internship, MS online internship, whereby when you are done, we are supposed to create a project based on what they've taught you. So basically, they train students or graduates or engineering students, and then they equip them and prepare them for career in IoT and embedded systems. So from there, what are embedded systems? They talked at what embedded systems are and what Internet of Things are. So with the embedded systems, they are the combinations of hardware and softwares designed for specific tasks. They are the main brains inside many of our household devices, like in the pictures above, right corner, you see the digital camera and all those things. So for example, as I mentioned, the digital camera is an embedded system that captures images, processes them, and stores them all within that compact device. Another example is the control system in an industrial environment that manages robotic arms and conveyor belts. So as you can see, we have robotics over here, robots. They are all embedded systems. So the next thing is the Internet of Things. So the Internet of Things takes the embedded system a step further by connecting them to the internet. And something like a smartwatch, they don't only tell us time, but they also track our health metrics and send us notifications. So with that, you can even make call with what? Your smartphone, whilst you are connected to your phone and internet. So the smartwatch is an example of Internet of Things. Our smart homes too, they are smart homes whereby you control your device, your bulb, your fans with what? A smartphone or a wireless remote. Someone can mention, is drone an embedded system or IoT? Drone is an advanced example of Internet of Things because what? It combines the embedded system with the IoT to navigate, capture data, and communicate it back to the central system in real time. So your drone is somewhere far, you have a controller, you're communicating with what? The drone via a wireless system, whether radio frequency, internet, Bluetooth, or IR. So what are the requirements for this project? We have the LED, which is light emitting diode. We all know about it. They serve as indicators or status light for most of our home automation systems. Then we have the temperature system, which comprises of temperature, heater, and then cooler. We have the LDR, which is a light dependent resistor. It senses light levels in the environment and can remote tank. We have Internet Shield, Blink IoT, Pacing Lab, Ubuntu is the operating system I'm using to build this project. And then we have the TTY0TTY, which is the serial port emulation. Okay, so now the next thing is the Arduino. The programming language that we use in this project is C++, which is the Arduino IDE. We write our codes in the Arduino IDE. Most of the syntax we use are the pin mode, digital write, digital read, analog write, analog read. For the pin mode, they have their syntax. So if you write the pin mode, you declare the you enter the pin and then the mode. The mode can be either input or output. So if the device you are connecting is an input device, the mode will be input. If the device you are connecting is an output, this will be output. And then the pin is the number. So if you connect it to Arduino pin 13 or Arduino pin 12 or 1, you write the value there. And then we talk about declaration of variable. So if you declare the pin number as LED 1, over here you write LED 1 instead of writing the pin number, which is 13. And then we have the digital write. With the digital write, it can either be high or low. When it's high, meaning on. When it's low, meaning off. And in the programming embedded system, high is represented as 1, low is represented as 0. Same applies to the analog too. We have the pin and then the value. The pin is the pin number of the Arduino board. So if you connect it to analog A0 or A1, you write it there. You can choose to declare the A1 or the A0 as a variable. Then you put the variable there instead of the pin number. And then the value is what you write, either the high or low. And next thing is the but we should know that with the analog read write or analog read, we are dealing with analog inputs, but there should be ADC which converts the analog to digital for us to see it on maybe our screens. Okay, the next thing is the Blink app. So in order for us to control our devices, we need an app called Blink, where you create your project. You create your project, you design it, or you do a button for maybe LED button for. When we get to the main the demonstration, you understand it better. Okay, this is a Pixel Lab, which means Programmable IC Simulator Laboratory. So I made a mistake. I should have added I in between the S and M. Sorry. So it contains microcontrollers, or Arduino boards, and then the virtual devices. All of these, they are virtual devices. They are all virtual devices that you get it from the Pixel Lab, and that's what I use for the project. So with the design and implementation, we started with first project, which is garden light control. From there we moved to the temperature system, and then the water tank inlet and outlet valve. We combine all these projects to form the IoT based home automation system. So let's talk about the garden light. With the garden light, it's having LDR sensor, which I previously said it senses the environment. It senses the environment, and once it senses the light, it automates the lighting. So if the LDR sensor it's an input device over here, it's an input device. So when you reduce or increase this resistance, it affects the light. So you will see it in the demonstration. We have the temperature control system. So this is the Blink app, this is the Arduino board, this is the screen, and then this is the temperature system. So the temperature system contains an input and then output. The input over here is the temperature, and then we have the heater, and then we have the cooler. We have the Blink app, which when you click on a heater control, it controls the heater over here, and when you click on the what's the name, the cooler button, it controls the cooler over here. All these communications displays on the notification on the app and also on the screen. So if I turn on the heater, I'm supposed to see a notification over here or a message over here, and I'm supposed to see a message over here. If I turn on the cooler to the same thing, I need to see or check or view the messages here and then here. If the temperature is reading, we have a reader over here, a guard, where it will be reading, you will see it. When we get to the demonstration, you will see it. But in the code, we said when the temperature exceeds 35 degrees, automatically the heater should go off. When we come to the water tank inlet and outlet valve, we added a water tank to it. So that one we have what? Two outputs, which is what? The inlet valve and then the outlet valve. We declare the same thing, or we design the same thing inside the Blink app, whereby when you click on the inlet valve, you turn it on, automatically this one turns on, and when you turn off the outlet valve, the same thing happens over here. So the inlet valve allows water to enter the water tank, and the outlet valve allows water to go out from the outlet. So when you turn on the inlet valve, water will start flowing inside, and when you turn on the outlet valve, water will start flowing out. All these things, you get the notification on the LCD screens, and then the terminal or the notification on the Blink app. So this is the result of the compiled at the end of the project. So this is the water tank project. Over here, this is the temperature system where the fan is, and then we have the LDR project, which is the garden light. So there is a bar over here. When I increase it, the light turns on. When I reduce it, the light goes off. So in real life, you don't need to control these things. It's the sun that will help us achieve the automated light. And then when you turn on the cooler, you click on this on, the fan will start turning, and over here on the screen here, it will alert you, and at the terminal here on the Blink app too, you get a notification. Same applies to the heater. When you turn on the heater, you see it moving here, you see it moving here, the T, where the T is temperature, then you see it over here too, that it is moving. But when it gets to 35 degrees, automatically it will shut down. The heater will go off, because we've written a code that prevents it from exceeding 35. We are able to communicate the Blink and then the Arduino or the PC lab through this Wi-Fi shed over here. So if there is no Wi-Fi shed, there is no way you can control your devices with the Blink app. So I'm going to do a demonstration. So instantly it's on because the water tank is empty. It will start going on. If I try to off it, it will still turn on because it's less than 2,000 liters. You can see it over here. If I try offing it, it will turn on, but you can see the reading because it's less than 2,000. See, right? It's more than 2,000, so I can turn it off now. So right now, when I turn it off, it's off because it's more than 2,000. So I can empty it again. So let me empty it. I'm emptying it. It's around 2,000. So it's off. So it's on. So there's nothing going on. So off is failing because this is on. I can off it again. The next thing is the cooler. When I clean on cooler on, the fan starts working. I've been alerted that cooler is on. Over here on the screen to what? Cooler is on. When I off it, tell me that cooler is off. What? Cooler is off. Let me turn on the heat. Turn on the heater. So the heater is on. You can see it reading here. You can see it reading here. And then what? They say the temperature is more than 35 degrees. So far as it's more than 35 degrees, to turn it off automatically. So this is the notification for the water tank, and the top one is for the temperature and the cooler. Anything that happens, you see it here. Here is the LDR. When I increase it, the light comes on. When I reduce it, the light goes off. This code over here is for the garden light control. You declare the pins. You declare the pins over here, the input and the output over here. And then for the serial tank to the same thing. This is the code for the serial tank. The temperature, this is the code for the temperature code. Then we combine all these things, we call them all inside the Blink app. We call them all inside the Blink app. So we have the setup where we called this is for what? The garden light. And then this is for temperature system project. And then finally the serial tank project. We call all of them there. And as I said earlier, we use the Blink. We call the Blink tool here so that we can operate it. This IoT based home automation project showcases the potential of what? IoT technologies in our everyday life. It has been an excellent learning experience, providing me with what? Experience in IoT development, sensor integration, and mobile app interfacing.